Our next set of examples have some different kinds of things going on, but just a reminder, if you have y equals negative 3x over 2, that's linear. You should see that the slope is negative 3/2 right away, but if you don't, you could rewrite it, pull the coefficient off, and then it's x to the first. So now when I take the derivative, multiply down, that would be a negative 3/2 x to the 0 when I subtract 1. So this will be y prime equals negative 3 over 2. For the next problem, what if you have a negative exponent in the denominator? So this is y equals 7 over 3x to the negative 2. It's important to note that the negative 2 is only on the x, not on the 3. So we'll look at the difference between that and if it was on the 3 as well in just a second. So I'm going to say the coefficient is 7/3, and then I need to make it x to a power up in the numerator. So this is x squared. If I move it down to the denominator, it's x to the negative 2. I can move it up and get rid of the negative. Now when I take the derivative, I multiply down. I'll have y prime equals 14/3, and then it'll be x to the first power, so I'll put that in the numerator. The other way to have looked at this is, what if it was y equals 7 over 3x to the negative 2? Then you need to get rid of this set of parentheses. So this really is 3 to the negative 2 times x to the negative 2. So if I rewrote this 3 to the negative 2 is going to put a 3 squared in the numerator. I bring the x up and I have an x squared. So now when I do the power rule, I'll multiply down, so that's times 2. And what I have here is 7 times 9 is 63 times 2 is 126, x to the first. So I'll have y prime equals 126x. For our next problem, okay, so what if you have multiple terms? Then you just do this one term at a time. So I'll say f prime of x equals, and the derivative of x cubed, multiply down, subtract 1, is 3x squared. The derivative of negative 4x, this is an x to the first, so multiply down is negative 4x to the 0, which is just negative 4. And the derivative of 5 is 0, 5 is a constant. So our derivative is f prime of x equals 3x squared minus 4, and that problem is done. If you have a function that looks like this, g of x equals negative x to the fourth over 2 plus 3x to the third minus 2x, you might need to rewrite one term of it, and that's fine. So I'm going to pull the coefficient off. This is a negative 1/2 x to the fourth. Now when I multiply down, I have 4 times negative 1/2, that's a negative 2 x to the third, and then I can keep going. This is 9x squared, and this is to the first, so negative 2x to the 0, so just negative 2, and that is my g prime of x. For my next problem, what if you are actually dividing by an x, not a number like we did on this problem, and we have multiple terms? So let's look at this one. F of x equals x cubed minus 4x plus 5, and it's completely divided by an x. Now you're only going to do what I'm about to do if there's one term in the denominator. So the way I think about it is, y'all already know how to fix this a little bit. Imagine you were solving for y. So 2y equals 3x plus 5. You're trying to put something in mx plus v form. So you divide both sides by 2. Well, there's one term down here, and it's very easy to split up. I'm going to divide this by 2 and the 5 by 2. So I know the slope is 3/2. Well, I'm going to do the same thing here. This is option 1. So I'm going to take this x and I'm going to put it underneath each one. So this would be an x cubed over x minus 4x over x plus 5 over x. And then I could simplify it. X cubed divided by x is x squared. These x's cancel out, so minus 4. Then I could rewrite this as a 5x, it's to the first, but it's underneath. That's one way to simplify this, and then taking the derivative is fairly easy. Another way to simplify it, it's doing the same thing but thinking about it in a slightly different way, is to say let's have x cubed minus 4x plus 5, and I'm going to bring this x to the first up, which means it has a negative exponent. Now I'm going to distribute my x to the negative 1. And when you multiply two things with the same base, you'll add the exponent. So x cubed times an x to the negative 1, that's 3 plus a negative 1 is x squared. This is an x to the first, so it cancels out with this x to the negative 1, making an x to the 0, so minus 4, and then plus 5x to the negative 1. So you can see I have the same thing either way. Now when I take the derivative, I'll multiply down 2x, subtract 1 is to the first. This is a constant, so the derivative is 0. Then I'll multiply down minus 5x, subtract 1, negative 1 minus 1 is negative 2, and that's my derivative. So I would rewrite it, f prime of x equals 2x minus the 5 is in the numerator, and I have an x squared in the denominator.